So we're doing Unit 11, Day 8. And if you're listening to this, you're stuck at home. I tend to talk faster when there's no audience in front of me, so you might have to pause the video and fill in the notes and start it back up and go back and forth. But to finish up the beginning trig unit, we're going to talk about radians. Radian is a different way of measuring angle. For those of you going on to pre-calculus, you'll do it a lot next year. But the definition of a radian, radians are measured, or an angle that measures 1 radian, is a central angle, and the arc that it intercepts, as in the picture, will be the same size as the radius. So if the radius is 10 and the arc is 10, the angle is 1 radian. If the radius is 2 and the arc is 2, the angle is 1 radian. So it's due to relative size rather than specific 1, 2, 3, 4, 5 degrees. So 2 radians is when the arc length would be twice the radius. 3 radians is when the arc length is 3 times the radius, etc. We are not going to deal with the formula that it says we're going to memorize, so we're just going to cross that off. So given a unit circle, what is the arc length of the entire circle? Everything we do with radians is going to be based on this concept right now. So the arc length of an entire circle would be the distance all the way around the circle, which is known as the circumference. Okay, now let's talk about the unit circle. Okay, so let's do unit circle. And we know from geometry that circumference is equal to pi times the diameter, or 2 times pi times r, which is the radius. Well, the radius of a unit circle is 1. So if I fill that into the formula, then the circumference of a unit circle is just 2 pi. So the angle that represents the entire circle, which we know is 360 degrees, in radians is referred to as 2 pi. So now, using that as a guide, we are going to label our quadrantal angles in terms of radians. So we know that we start on the positive horizontal axis. We would know it as 0 degrees, and we would also know it as 0 radians. And I also know if I go all the way around the circle and come back, I'm at 360 degrees, which we just said was the equivalent of 2 pi radians. So knowing that the entire circle is 2 pi, that would make halfway around the circle 1 pi. Which would make up here at 90 a half a pi. So we call it pi over 2. Okay? So I took the pi, cut it in half, and I got up here. Well, then I've got 1 pi right here. I've got 2 pi right there. What's halfway between 1 and 2? 1.5. So 270 down here is 1.5 pi, which we'll write as a fraction as 3 pi over 2. So those are the equivalent radian measures of your 90 degree, 180 degrees, 270 degrees, and 360 degrees. And those are going to come up often enough that by the time you get done, you'll have them memorized whether you try or not. So the big thing with today's lesson is to learn how to convert degrees into radian measure and back again. These formulas are in fact on the reference sheet that you are given for the Regents exam. Doesn't hurt to know them anyway, but if you are going to convert degrees to radians, you are going to multiply by pi over 180. And if you're going to convert radians back to degrees, you're going to multiply by the reciprocal, 180 over pi. It's that easy. Let's practice. Convert the following angles from degrees to radians. So if they give you degrees, you need to multiply by pi over 180. We are going to leave our answers in terms of pi, which means the pi is going to stay in it. Now you have 2 ways. The wimpy way is to multiply straight across and get 30 pi over 180. And then you could type 30 over 180 without the pi and hit MathFrac in your calculator. Or, that's the fast way, that's the cheap way. Those zeros will cancel out because they're divisible by 10. 3 goes into 3 once. 18 can be divided by 3 6 times. So sum total, you end up with pi over 6. If you're going to take the easy way out and do MathFrac on your calculator, don't forget to put the pi back. All right, 60 degrees. Multiply by pi over 180. So straight across, we get 60 pi over 180 pi. Again, you could take the 60 over 180, do a MathFrac in your calculator and put the pi back on. Or they're both divisible by 10, so that wipes out the zeros. 6 goes into 6 once. 6 goes into 18 3 times. So we end up with 1 pi over 3. So 60 degrees is pi thirds radians. 45. Again, multiply by pi over 180. And you could do a MathFrac or a couple times of simplifying, but 45 goes into itself once. 180 divided by 45 makes 4. So 45 is pi fourths radians. 600. Multiply by pi over 180. So we know that this angle goes around more than once. It's okay. We still convert it to radians the same way. Divide them by 10. The zeros get knocked off. And let's see. 6 goes into 60 10 times. 6 goes into 18 3 times. So we end up with 10 pi thirds radians. And the negative 200 times pi over 180. Negative 200 pi divided by 180. Divide them both by 10 and knock off the zeros. And looks like 2 will go into both. So 2 goes into 20 10 times. 2 goes into 18 9 times. So we get a negative 10 pi over 9 radians. Now we're going to take radians and change it back to degrees. So when you change them back to degrees, you multiply by 180 over pi. So on the top, I now have 360 pi over 3 pi. The pi's will cancel out, and 360 divided by 3 is 120 degrees. Make sure you put your degree symbol on it. Radians does not have a symbol or a label, it's just radians. Okay, this one, convert from radians to degrees, multiply by 180 over pi. So that's going to give me, let's see, 7 times 180, 1,260 pi. In the denominator, I have 4 pi. So the pi's cancel out. 1260 divided by 4 is 315 degrees. Not all radian measures will have pi in them. You will see that with other trig things that we do. So here's an example. We have negative 3 radians. No pi involved, but we're still going to multiply by 180 over pi. Usually with something like this, they would give us the direction to find the measure, find the exact measure, which means we'd leave pi in the answer. Since it's an irrational decimal, we can't convert it. So let's do that, because that's what we're most likely going to see. So we get negative 540 over pi, and that's where we're going to leave it. That's how many degrees, put our little symbol on it, we have. They might tell you to round it to the nearest tenth, in which case, negative 540 divided by pi, rounded to the nearest tenth, would be negative 171.9 degrees. So it all depends on what the directions say. Okay, day 8 is the homework that goes with this lesson.